We are gathered here today to solve this wonderful dynamics problem, and we have a drum of 60 millimeters, and it is attached to a disc of 120 millimeter radius. The disc and drum have a total mass of 6 kilograms and a combined radius of gyration of 90 millimeters. A cord is attached as shown and pulled with a force P of magnitude 20 newtons. Knowing that the disc rolls without sliding, to determine the velocity and angular velocity of the drum after 5 seconds, and the minimum value of the coefficient of static friction capable with this motion. And this problem needs to be solved using the method of impulse and momentum.
Jeffrey, my effects.
Here you are, sir.
Thank you, Jeffrey.
You're welcome.
Okay, so now we'll discuss the givens, what we need to solve for the problem, and the assumptions that we make. So here are the list of the givens. D1 right here is the first radius. D2 is the radius of the bigger disk. They're attached, so they're going to move together. The mass of the whole system is 6 kilograms, right there. Radius gyration is 90 millimeters. The force acting tangentially right here is 20 newtons. And the time elapsed is going to be 5 seconds. So this force is going to act on there for 5 seconds. What we need to solve for this problem are the angular velocity, translational velocity, and we need to solve for the coefficient of static friction. Other unknowns that we're going to use to get there are the normal force and the force of friction. The assumptions that we make at the beginning are that the system is initially at rest. That means the leftward motion is going to be 0, so no velocity and no angular velocity. Also, we assume that left is the positive direction.
In order to solve a problem, we're going to use the principle of impulse and momentum, which is a variation of Newton's second law of motion. These principles consist of 3 equations. We will first use the third equation by summing moments about the object's centroid. That will allow us to directly solve for velocity and angular velocity. We will then implement the 2 linear equations in scalar form in order to solve for the rest of the unknowns. The impulses, which are in the middle here, will be reduced to simply multiplication of the time, which is 5 seconds, by the significant quantities here. And that will allow us to solve for angular velocity, as well as the static coefficient.
So essentially this is how it's going to work. The disc is the outside of the yo-yo and the drum is the inside. Alright, so for step 1 solution, we have this equation, moment of inertia times the angular velocity plus the sum of the integrated moments with respect to time equals the moment of inertia times the final angular velocity. This goes to 0 because the system's initially at rest. Plug in the rest of our givens, where inertia equals mk squared, and we get a function of the friction in terms of the angular velocity. For step 2, we do the same thing with momentum. Plug in the givens, where velocity equals radius times angular velocity, and we get another equation for the force of friction with respect to the angular velocity. We combine these, get that the force of friction is 6.4 newtons, angular velocity equals 44.4 seconds. A little extra stuff here to figure out the normal force. It is not equal to the weight, it is 38.86 newtons. Then we use kinematics for the velocity times the radius times the angular velocity, and we get 5.33 meters per second. And you get the static friction by doing the force of friction divided by the normal force equals 0.165.